Welcome. In this video, we are going to be discussing expressing numbers as decimals or integers. Now, this is basically the same as converting from standard form to ordinary numbers. Ordinary numbers being the decimal or integer form. Like what would be the normal way of writing numbers? Like we've already discovered, standard form is when we have a number written in the form of a times 10 power n, where your a is in between 0 and 10. That is, it is bigger than 0, but it is smaller than 10. Okay, and then the ordinary way or integer decimals is where you would have a number like 0.007 or 56,000. So what are we looking at today is a way of converting from this form, standard form, to the ordinary form, or as integers and decimals. And the method is basically multiply out. I'm going to add there divide out, because at some point it becomes a division. So for example, if I have a number which is 5.7 times 10 to power 3, I will be multiplying out. And multiplying out in this case, I mean multiply by 10 power 3. We know that 10 power 3 is the same as 10 times 10 times 10, which is 1,000. And we also know that if you're multiplying a decimal or any number by 10, 100, or 1,000, basically the numbers which are multiples of 10, we move the decimal point. For example, my 5.7, the decimal point will go 1, 2, 3. 3 steps. And I'll put zeros for those blank placeholders. So my answer will become 5,700. This is what I mean by multiply out. Let's take another example. If my number is, for example, 3.52 times 10 to power 5, it's going to become, I'm going to move the decimal point 5 times, so that is 1, 2, 3, 4, 5, and I'll place zeros in those placeholders. So my answer becomes 352, 1, 2, 3, 4, 5, 3, 5, 2, and 1, 2, 3. So this is 352,000. What if my power is negative? So in the next example, I'm going to use a power which is negative on the 10. Let's say I have 7.3 times 10 to power negative 4. Now, from indices, we learned that the negative, when we have a negative power, we flip the number, the base. Okay, so this would be the same as 7.3 times 1 over 10 to power 4. And I know that 10 to power 4 is 10,000. So it's basically 7.3 divided by 10,000. Now, once again, in multiplying and dividing by 10, 100, or 1,000, we still can just move the decimal point. This time, because it's division, the decimal point moves to the left. So if I have my 7.3, decimal point is going to go 1, 2, 3, 4. And I'll still put my zeros in the placeholders. Now, please note the decimal point is now here. So my answer in this case becomes 0.00073. I can do some checking to see whether I'm correct, especially if the numbers are really huge, like 10 to the power negative 10. You need to make sure you don't leave out a zero. So my check would be to find out whether if I move the decimal point back to there, I'll have taken 4 steps. So that would be something like 1, 2, 3, 4, which means that I am correct. So my answer becomes 0.073. Now, when you're working out, you don't have to do all of this. Okay, you can just go straight away to moving that decimal point 4 steps to the left, because you know what 10 to the power negative 4 will mean. That times 10 to the power negative 4 is basically divided by 10 to power 4. So let me give another example where I'm not going through all those steps. So if I have my number as 3.68 times 10 to the power negative 5. Now, if I'm writing this as an integer or decimal, so in this case it will be a decimal, I'll basically move this point 5 steps to my left. So that's 1, 2, 3, 4, 5. So it's over that side. So that's 1, 2, 3, 4. So my answer is going to be a 0.0000368. I can always check. It's important to check. So that would be 1, 2, 3, 4, 5. Yes, okay. And that is my answer. In this case, this is my answer. So once again, depending on what you are doing, when you're converting from standard form to ordinary numbers, it's going to be either multiplying out, that's by 10, or dividing by 10. For multiplication, you move that decimal point to your right. For division, you move that decimal point to your left, and that is your answer.